So first off, I think Maggie put something up here. Where's Maggie? Yes, there you are. So we have a Twitter account for KITP, and I know it was bound to happen. So for those of you who are on Twitter, we're using it to sort of send out things that have happened at the Institute that we think the world should know about. And so as high school physics teachers, you probably would like to know about what's going on. We're not overusing it, but we are using it. So I'd encourage all of you who are more modern than myself to go ahead and use that. And I think otherwise, we also have set up an explicit YouTube channel. That's something that Greg Huber started before he left, where we're taking some of our online talks that we feel would be of more broad interest and highlighting them on YouTube. And that now also is something you should be able to find. We just got a real name for it. Is it yesterday? It finally got a better name? YouTube gave us a better name?
Yes. I'm going to stick with your...
Yeah, as one run-on sentence, yeah.
Are they still available on the website?
Absolutely, everything's still available on the website. So the online resource is something is important for you to know about. You can find it on our website, but it is all of the talks here at KITP for roughly the last almost nearly 20 years. There's about 18,000 talks, including the teachers' conferences. So what's happening today is being recorded. And those talks are available for streaming, and certainly are probably a resource for all of you for allowing your students to go or yourself to go and see what's happening here, but also old public lectures, sort of everything is there. And so typically our usage is about equivalent to 4 people around the world watching 24 hours a day. That's roughly one way if you want to think of it. We don't know who those 4 people are. So what I'd like to do is start a discussion, and so we definitely want to be certain that we use the microphone. So Sid's and Craig is here, and I'd like to start by asking anybody who has a sort of a new technology or a new resource that they're using in their classroom that they'd like to tell others about. So the goal here is to stir the pot and also get prepared for when we're at lunch. There might well be some of these discussions continue. So who would like to share with anyone a new resource or a new technology they're using in their classroom that they feel like others should know about? Okay, just wait for the microphone.
It's not necessarily new technology, but it's a new application of technology for me the last couple of years. And I have my students do an independent study project where their cell phone or their smartphone has to be the primary way of collecting data. Seen some really clever uses from my students. I give them a long time to think about it, give them quite a while to work on it. And so I've seen, for instance, one that stands out was one student who used his phone as a frequency generator, played through an aux cord, played through the car stereo, and another student who used the frequency analyzer on their phone, and then they drove by the frequency analyzer at increasing speeds. I mean, they've done some really clever things, and all with the built-in sensors that are in the phones.
You're all physics teachers, so come on. Any new demos? You got new demos today, obviously. But these are old school demos. There's a new school demo. Yep. Hang on, let's wait for a mic.
One of the things, this is my coworker, so we share a lot of things. And there is this website called EdPuzzle, where you can just upload videos, YouTube videos. You can create videos of your own, but throughout the video you can chop it or ask questions to your students, and they have to log on to it. If you have Google Classroom, it will automatically import your students to it, but you can look at their progress. So if you use a flipped classroom or something like that, it could be a really good way to assess your student understanding of a topic. And we've also had our students with their phones create stop motion videos. And so they can create a stop motion video to show a Newton's law, like an object in motion stays in motion. So they would take, like, get a push, but not really a push, but take different pictures as the object is moving back to just show a Newton's law, because usually, truly, they don't work. But like it can show, something going in circular motion and taking away the string, and then the object will continue to go in that circular motion. But just using stop motion videos, because they're taking a whole bunch of pictures and then putting them together at once.
Actually, I realized I was going to ask where everybody's from. Can you say where you're from? I should have asked that.
I am.
Because also there might be some, sorry to interrupt, but there may also then be some local synergies of people within driving distance or whatever, so please.
I'm from Chicago, and I teach at Walter Payton High School.
Okay. Oh, we've got one back here.
Going along the lines of the folding, there's a website, just fold.it.
Folds.it?
Fold, F-O-L-D,
Oh.
.it. And it's kind of like a crowdsourcing way of folding proteins, where kids learn how to, I might be the only biologist in the room. I kind of usually feel that way when I'm here. But it's nice because they get to see how proteins fold. They understand the chemistry behind it. They understand just the dynamics, and it gets a lot into what Arvin was talking about, how certain molecules can only take certain shapes in certain ways, and ultimately the kid's information is going to be used to help truly understand protein folding. So you get into DNA analysis, you get into, everything's made out of proteins, for those of you that don't know that. So you're non-biologist people.
And where are you from? Sorry.
Oh, I'm Hartford, Connecticut,
Okay.
Prince Tech.
Okay.
So one of the things I've been doing, I teach honors physics. I use Faro Robots, which are small circular robots that not only students can learn how to code either through just drawing, through block programming like Scratch, or by using Swift, but the robots also collect data, displacement, velocity, acceleration, rotation. So their final project this year is that they have to design and construct a miniature golf course, but then they have to use the Faro robot as the ball.
How do you spell it?
S-P-H.
It's Sphero?
Yeah,
Okay.
S-P-H-E-R-O.
Okay.
So it's their concluding project for the year is they build a miniature golf course, but then they have to code the ball to go through their hole. And then the data that they collect is their final lab project for the year.
And how long does that take? What's the?
We start it next week. We do introductory stuff, and then their main work is the last half of April and all of May.
And where are you from?
Marymount in New York City.
Right, thank you.
My name is.
Well, hang on. Let's get the microphone.
My name is.
Right. Patience.
Ratnakar Amarwadi. I teach at Natick High School in Natick, Mass. My department has been investigating a tool called Autocrat. Maybe many of you have used it. It's for automated grading of student work, and you provide.
Autocrat?
Yeah, A-U-T-O-C-R-A-T.
Okay.
Autocrat. And you provide a sample solution to a problem, and it has, and then it uses that as a base, and tries to do some kind of recognition on student work. Very rudimentary, but it's not on the instruction end, but on the teacher end of stuff.
Yeah.
My name is Lisa O'Brien, and in Poway near San Diego. This is non-techy, non-new. It's just a demo that I use for students to understand circuits. So I use a grocery store analogy, and I just have little strips of paper, so you don't need tech or a lot of money. And you have one loop in the classroom, and you're like the ATM, so you give each person who comes by a certain number of volts, and they have to see what cashiers they have to pay and how many volts they give to each cashier. And then you can do a simple series circuit and a simple parallel, so they see that if you go to one of the parallel branches of the circuit, you're going to give them all your volts. You're not going to run around and save half of them and give them to the other cashier. So it's just kind of a simple demo with grocery stores that have helped them understand a lot more than the traditional waterfall analogy. Kids don't play with hoses. They have no idea what you're talking about with that analogy anymore.
Cheryl, one. Okay. Hang on, Cheryl.
Hi.
Go ahead. Yeah, go ahead.
You sure?
Yep,
Okay.
sure.
All right. I volunteer with this group called CPEP, the Contemporary Physics Education Project. And two things with this. We've already had posters and materials in fusion and particle physics, nuclear and cosmology, but just recently we started and have a new set of materials that deal with the gravitational waves and LIGO. So that's something a little new. And we're also, and I know this is very short notice for everybody, but we have a teacher's award. The deadline this year is February 28th, so it's coming up very soon. But it's a $250 monetary award along with some CPEP materials for anybody who is interested in teaching and does teach contemporary physics in their classroom. So it might be worth checking it out. It's hopefully going to be a yearly thing. So it's
And that's through CPUP? Or?
CPEP.
Oh, PEP, sorry.
CPEP.
Yeah, sorry.
CPEPphysics.org.
So this is along the lines of robotics and programming. I've been using the Raspberry Pi and specifically the Sense Hat. It has multiple sensors on it, gyro, accelerometer, other things, pressure. They also have a LED array on it, and there's an awesome resource that goes along with it through AstroPi. Basically, if you go online and you have no idea what you're doing with code, they have wonderful resources for your students and teachers alike. So,
And where are you?
I'm a City College student. I got dragged along with these guys over here.
Okay. What's the cost of the Raspberry Pi these days?
I think it's $30.
$30. Yeah, okay.
Well, my name is Manny Aldana, and it's not really new, but it's new to me. I just found out about it. But apparently, Fermilab and LHC is trying to do more classroom-based activities, and they're trying to make it more accessible to teachers. So, not sure if you guys are aware, but they have simulations where students can actually access actual data of the particle colliding from the LHC, and then they can go ahead and try to find anything. You know, they can analyze momentum vectors from the particles. They can go ahead and try to see the types of collisions and try to detect some particles if they can. And I think the focus is more analyzing big cluster data as opposed to just gathering small amounts of data. So something I think I'm going to use that this year for is kind of like an AP class where they take their AP exam sometime in May and then they don't really have anything to do. So a little bit more in particle physics.
That's great. Looks like we got some here.
Recently, some kids at MIT made a cosmic ray, a muon detector for $100 in a kit. And it's if you go to Cosmic Watch.
And you've used it? What? You've used it?
We're building one. We're building one now, and we're going to send it up in a balloon.
Okay.
Just to follow up on the particle physics, LHC, Fermilab end of things, there are a lot of, one place you can go easily online, quarknet.org. I know a lot of people have heard of QuarkNet before, but that's, if you go to the data portfolio, it's called, there are a lot of scaffolded lessons working with data that involve large data sets. But another cool part of it, so it's not only working with modern or 21st century physics, but it's also applying things like conservation of energy, conservation of momentum, et cetera, things that you're doing anyway in an introductory to physics classroom. So there are a lot of resources there, and there are more on the way soon. So keep watching that site. And yeah.
That's great.
Oh, you did say where you're from.
Oh, I'm from a school district outside of Minneapolis, in Minnesota, but I also work with QuarkNet as well, part-time. So.
I'm from a school in West Los Angeles.
Sid, we've got one here. Looks like. Thanks.
I'm the last person you want advice from on technology because I have taught for so long. But what I found particularly useful coming right out of these meetings was a unit I would put on particle physics for all of my classes, not just my better classes, because I wanted students to know what physicists do. And I made use of particleadventure.org. And I also pulled out from, I don't remember the source, the picture of a collision where you can measure the energy and calculate. And I also used something off of Fermi website, which never worked for me, except the kids did have practice. And this was just a regular physics class. They had practice interpreting data and looking for things. We never were able to complete it, but they had so much fun acting like physicists that I thought this was a superb thing. And I also want to mention one thing. I never liked to use the when you're doing your motion studies, I never liked to use a computer because I thought using the dots, and I don't know if any of you know what I'm talking about, but the little timers where they can actually visualize the difference in the distance. After that, I'm fine with the computers, but at the very beginning where you want them to internalize a lot of things, because I worry that they're going to know how to solve problems without even knowing what they're solving and what they're doing with them. But that's what I wanted to add. And I did most of my teaching in New Jersey. I now live in New Mexico.
I'm from Brooklyn, New York, and I just wanted to mention two places that were very useful to me. One is Perimeter Institute in Canada that has some good videos about quantum mechanics and dark matter. And the other is that CERN is running a contest on a website called BL4S, where classes can invent an experiment to do at CERN. And
Say again what it was called?
BL, all caps, BL, and then the number 4, and then capital S.
Okay.
Look that up. And it's a contest where you try to think of an experiment to do at CERN, and if they like it, they'll fly you there and you get to do it, which is really cool. And of course, it's fun just to think of projects.
There's a magazine, an online magazine called Quanta Magazine, and it's readable and it's keeps up with almost daily new ideas in physics and math. And then the last thing I can think of is there's a website that I go to buy electronics. It's called AliExpress.com, and they have you can get a Tesla coil that changes music into it's one of those music. It takes plasma and changes into a music.
How do you spell the website so I can get something up here?
ALIE Express.
AliExpress.com.
And it only costs $7.
$7?
$7.
Did I get it right?
No, just one E.
One E, okay. These things are unguessable. On Quantum Magazine, let me just add that this is something that was started by the Simons Foundation about 2 years ago. Their writers that contribute have come out here for long-term stays. We have a journalist in residence program. Natalie Wolkover was the first to come, and you're absolutely right. It really is a fantastic resource. So they do physics, mathematics, and biology are the 3 disciplines they focus on. And their stuff does get pushed out a fair amount to other places, but it's probably now the leading long-form science writing. This is in some sense all we have, unfortunately. It's great, but there's not a lot of it. Please.
So one more is Zooniverse, and it's a kind of a crowdsource way of having citizen scientists look at data from actual research projects.
Yeah. How do they spell it these days?
I think there's an N and a verse.
Huh? What do you think they do? It's not Zooniverse, right?
No, Zooniverse.
Zooniverse. Okay. All right. I can do that.
I instead of a U.
Huh?
N-I.
I can. This is for galaxy imaging. Is where it started, right?
Yes, there's other applications now.
Yeah. Oh.
Santa Barbara City College.
Got one over here too. We got one on the.
It's the spelling is Zooniverse, one big happy word, like universe, but just no U, Z-O-O.
No U.
ZOONIVERSE.org. And another one is Space Math.
Space Map?
Space Math. If you just Google Space Math, every quarter or so, NASA tries to put out a book that teaches math, but it also does it through physics, and it has to do with the problems that are presently being solved. So with the eclipse that just occurred, you could go to Space Math, and the kids can figure out all the geometry behind it. Or you can look up kinetic energy, and the kids will actually be given data of things that are happening on the sun, and they have to look at transfer of matter, or transformation of matter.
For just basic video clips, I like Veritasium. If you haven't used them before, they have like the new kilogram, and they do the double slit experiment out in the public and ask people what they think they're going to see and stuff. So they have some really cool Veritasium, I think.
ISIUM.
It's like an
Element of truth.
Okay, I got it. Element of truth.
They have an absolutely outstanding video of an analogy to, what's the word I'm trying to say? They have an analogy for quantum motion with little walking dots. You know, not Brownian motion. Excuse me, I'm having a senile moment.
So we'll come back. Don't worry.
Anyway, they have little bouncing oil drops, and they recreate quantum uncertainty phenomenon, like the double slit experiment. What happens if you cover one slit and figure out which way it's going through with macroscopic dots?
Good. I knew this would be stimulated emission. It's all everybody's getting there. We'll get you.
Minneapolis, Minnesota is where I'm from, and along with Veritasium, another site that I use frequently is Smarter Every Day. And then going back to a previous comment, or suggestion, I should say, is that a website that I recommend to my students frequently is Stellarium, and Stellarium, STELL and then Arium.
My name is David. I'm from beautiful Bakersfield, California. Okay.
And I got this, I went to NSTA National last year in Los Angeles, and I saw a very cool presentation. It's called earth.nullschool.net. Earth.nullschool.
Null,
N-U-L-L.
Okay.
.net. It's a Japanese website, and it's real-time atmospheric information taken from space, and you could do relative humidity, carbon dioxide, sulfates, temperatures globally. You can rotate the globe. It's an amazingly powerful tool. I do use it for AP Environmental Science, but I think I can squeeze physics in there for sure.
That's great.
It's pretty neat.
That's great.
Just one more thing. If you want students to interact with physicists, there's a adoptaphysicist.org or something. But it's a lot of fun, and the kids were able to communicate. Again, I'm trying to get them to become physicists.
So for the last sort of few minutes, maybe we'll transition a little bit to also asking, well, I guess maybe some of this maybe got already addressed, but somebody mentioned a flipped classroom. And I know obviously at the university level, a lot of people are doing that, but I don't know if there's, I mean, this may be a moot question now because all of you might be doing it, or maybe none of you are allowed, I'm not sure. But is there anybody who's had let's say, a positive experience of how to achieve a flipped classroom in a high school that they want to share? Or even a negative experience? Or any experience? Cheryl, hang on. Oh, wait, sorry, let's go ahead. Yeah, please.
So I started with a teacher who was trying to do flipped classroom. So pretty much my whole experience has been trying to flip my classroom, which has had varying success at the schools I've been at. At the previous school I was at, we were able to get it outside the classroom and actually coming in with the videos done.
Could you say what type of physics in the spectrum of freshman versus AP? Where
junior level physics, algebra based.
Okay.
So, and it was I found a source, Flipping Physics, he does really high level physics videos. We actually filmed our own, but I kind of used those as a guide of this is what it could look like, and I found really good luck with when we filmed the videos, they tended to watch them more and get more out of them just because they were listening to us talk. Currently I'm doing self-paced / flipping my chemistry and physics classrooms, which I've really enjoyed because it's just allowed to have much more interaction. And I basically, as long as my observations go well, I haven't got any kickback from my administration but I was very lucky to get a grant where I got 1-to-1 in my classroom to do that.
That's great. Cheryl.
We cheat a little bit on this, I guess, but I've been using Bozeman Science. I don't know if you guys have experience with that, but pretty much 3-4 nights a week, I have the students prior to our lesson watch the Bozeman Science video, answer a few questions.
I presume this is Bozeman, Montana?
Yes, okay. Yeah. And they come in with questions. It's right at an introductory level for them. And so they come in with a little bit of prior knowledge. So it's not really a flipped classroom, but it avoids us having to go through as many notes. And they already come in with a little bit of basis of knowledge and some questions already. So it seems to be working well.
Looks like there was
I just want to follow up with what you were saying about your videos. I think like where EdPuzzle, that's kind of what we both use, could help is at the end of every video, I always add a question that says, do you have any questions? And that way I can walk into the classroom the next day without a huge lesson and all these demos planned, and they all come in like, we didn't understand anything. That way, right, and then your lesson's ruined. That way you can read through their comments before you walk in the next day, and you'll know, okay, crap, I have to start over with this, and I have to redo everything. Yeah, so that would be like a nice addition to what you're doing.
Another good site if you're not going to try to videotape yourself is thephysicsclassroom.com. They have informative tutorials, but then they also have interactives. So they have one on like free body diagrams. Instead of spending a bunch of class time on the first day going over how to do them, if they do that interactive at home and they can take a screenshot, they get a star for 12 different free body diagrams they have to do, and so they just bring in the screenshot that they completed that before class, so you can do a little bit more complicated stuff.
Hang on. You gotta wait for the microphone.
There is a web, I've not used it in a while, but University of Colorado has a FET physics. They have some very good simulations, but I've not gone into their website for a long time.
PHET, right?
Yeah, PHET.
Yeah.
It's a good resource.
Oh. Well, I'm going to leave physics here. I'm not going to erase physics. Yes, I understand. Yeah.
Sometimes I steer my students to Coursera. I don't know if you're there. They have Coursera and edX. They have very good.
Is that right? Is that how they're spelling it?
Yes, yeah. Coursera.com, I think. And the other one is edX.
As opposed to TEDx. Yeah. Okay.
I assign lab groups using random.org, and it uses atmospheric noise to generate random sequences of numbers. And so my students all have a lab number, and when it's time to do a lab or get into groups, boom, I do 8 sequences, and that's what they get. Yeah, works really good. And it's not always random, but.
Just to go along with the FET physics, the openstacks.org books, they are aligned with the FET physics so that at each section where there is a demo that can be done in FET, you can go to the program, and it's STAX. Yeah. And the books are free, and they're many different topics and subjects. There's chemistry, there's bio, there's AP physics.
Yeah. Okay. For free.
For free, yeah.
With that tie-ins, they download that my students. I make my.
Here, let's get a mic. Sure.
Yeah. David Hembroff. I teach in Montana, and I teach a couple concurrent classes in physics and chemistry, and I use their textbooks because they're college-level textbooks, peer-reviewed, as the students can download to their devices, and the links are built in for all the demos off of FET and other things already there. And my supervisors for my concurrence, they adopted the textbooks that I've been using for a couple of years now. So.
That's great. So I'd asked about the flipped classroom. Sounds like very few people have tried it, or they don't want to talk about it. And it may be a bad question. That's just fine. I'm happy to.
I'm not a high school teacher, but around 2011, I tried to flip a classroom, undergraduate class, at University of Connecticut. And maybe that was a lifetime ago now, but I had a lot of difficulties doing that. There was the technological difficulties of getting the clickers to work, because some of the clickers were using an antenna that I had, that communicated directly with the antenna. Others were based on the cell phones, which had to go up. The signal goes up to a satellite, then it had to go down to my to a cell tower or something. It had to go to my internet connection, on my computer. But I'd be interested to hear others' experience if they use clickers still, if that's passé. This was 2011-ish. Peer instruction was kind of the word of the day. You were supposed to put up concept test questions. It was a radical flipped classroom. I tried not to give a lecture, but just use these specially chosen questions that were supposed to ferret out the conceptual crises in their minds. And
I think
yeah.
we got somebody.
Okay. I just want to go back to what you said about having two things. Having your students create their own videos, I think, is really, really important because it gives them agency and ownership about what they've learned. But to go back to what you said about the flipped classroom, I think the worst thing you can do is have students sit down and just watch Khan Academy videos all day. So to go back to your question about the clickers, I have my students either watch videos, but then I use an app called Kahoot, which is on your phone, but they've just changed it now so that you can use it as a homework assignment as well, so that the students can, I give them a video and then about 5 questions that they can answer when they're watching it. One, I know that they've watched
guessing.
it. It's K.
You're in Kahoots. Got it. Okay.
But it's a really good way for you to check that they've watched it and then give them some questions. It gives you really good information for your next class going forward.
That's great. So hang on just a second. We got one here. Yeah, we'll get. Okay, go ahead, please.
A similar application.
Where are you from?
I'm from Dedham, Massachusetts.
Yeah.
Dedham High. So there's a similar application that I use. It's a website called Quizzes, and it's very similar to Kahoots. I like quizzes. Yeah. IZ instead of ES. So QUIZZIZ.
IZ, man.
Yeah, I don't know.
Well, because the other's taken, okay.
But I enjoy that one more than Kahoots.
More than
I
Kahoots.
used to use Kahoots, and now I use that
Okay.
one. It's a lot
we
of.
had one in the far corner.
Oh, sorry, I was gonna
Please.
add that there are a lot of resources that are already in place, so you can utilize public quizzes that are already there.
Huh.
So you can share yours, you can
Right.
edit.
Great. In the far back?
I'm from Oxnard, so you probably passed it when you were driving here from the airport. Along with quizzes, there's also Socrative, which also works well. If you are using Kahoot, just know, at least in the classroom, I don't know about the at-home, but the students can hack it. There are lots of apps out there that make Kahoot so that they're always getting the right answer. And as far as the students making their own video or you making your own video, I know probably many school districts, at least in California, are moving over to Google-based things. And there's a Google extension called Screencastify, SCREENCASTIFY. And that allows them to record using their microphone, but it's not a picture of them. You can put a little picture like the Bozeman Science videos, but if you have issues where students aren't allowed to be videotaped or something, it's just their voice, and then it goes right into Google Drive. They can put it on their Google Classroom, and then you can make videos as well for demos, for either flipping the classroom or just as resource.
So I got this wrong still.
Castify.
Screencast. CAS. Oh, Screencastify. Yeah. Got it.
Also, just with Kahoot, kids can tweet the code, and other people outside the classroom can join it. Kahoot. You gotta let your kids know in advance about some things, just if you try it for the first time. So with the clickers, there's also this app called Plickers that as a teacher you use your phone.
Like that?
Yes.
All right.
And the kids get something that looks somewhat like a puzzle piece as a QR code, and they will turn their puzzle piece a certain way, and you scan the room, and the data will show up about how the students stand score. So if it's a way for you to assess something the students know.
I'm Aaron O'Connor with Santa Barbara City College, but I just want to let you know that Jet Propulsion Laboratories, JPL, has all their Earth Science missions, And a number of years ago, they've made all that data available in a user-friendly manner to teachers and anyone from the public. But it's really fabulous. They've got really well laid out graphically, and you can access basically all the real-time data as well as historic data for carbon dioxide, sea level, global temperatures, and you can watch. You can literally watch the effects of global forest fires and things. All these forest fires and things. It's pretty incredible. But Eyes on Earth. Just search for Eyes on Earth.
Okay. Okay. So I wanted to transition because we just got a few minutes before lunch. I think we're good, right, Claudia? Are we good? Yeah. So very briefly. So the rule at lunch is there's going to be one of either the session chairs or the speakers at different tables, so that people should the locals should distribute themselves, I guess, is the short answer there. And I want to just so announce, so next year, the Teachers Conference will be associated with a program that we're having on many machine learning applications to, in this case, quantum physics. So we'll see what the Teachers Conference is, but it will definitely be centered on sort of impact of machine learning on physics research generically. So that's pretty clear. So it'll be in the sort of this same time of year. We haven't yet decided which exact weekend. But the one question I wanted to ask is, this was an unusual weekend because it was the President's Day holiday. And we have no idea whether that's better or worse for you. Well, you're the ones who are here, of course. But, but generically, we have to stay away from the AP period. We've discovered that fall kind of works poorly. I don't know, Maggie, do you want to say anything? Just to get Maggie a mic. It's a time for us to get a little bit of input, even though our experiences were those who are here. Maggie, please.
Well, you scooped one of my survey questions.
Oh, you scooped one of my, okay.
But please do answer the survey when I send it out. So actually, another question that I didn't put on the survey was, if we do this on a 3-day weekend, is it easier, do you want the conference to be on Saturday or Sunday? Because I know some of you had to take a day off school. So raise your hand if you want the conference on the Saturday of a 3-day weekend. Okay. Raise your hand if you want the conference on the Sunday of a 3-day weekend.
Right.
That was pretty clear.
But which 3 days? So Friday was the holiday, but for some Monday was the holiday for this weekend.
Ooh.
For how many of you was Friday the holiday? Nobody. So that was a Monday holiday, just to be clear.
Yeah.
Okay, just checking. Because local schools took Friday and Monday off, so I don't know the parity. Yeah. Oh, microphone, yeah.
First off, missing school is a feature, not a bug. Okay, definitely. I think I have done my best to get this information out to as many people as I possibly can.
Yeah.
And it's like dragging an elephant through mud. Oh, that sounds great. And then people always make up a reason not to. And so I don't think 3-day weekends really matter. I think if you have people who are interested in doing it, they're going to do it.
Okay.
3-day weekend or not. And so I just, we just keep pushing it out. We convince people what's going on. And works for me. I like it coming over here.
So how many of you are now following us on Twitter? Are. We got 6 new. Okay, we'll see. You don't do Twitter. Okay, all right, lunch.